Hey, y'all. I'm just going to give it a few more minutes for people to log on if they're running late.
Hey everyone, can you hear me? It's still raining here. So I'll be really quick. This is an interactive training, and we really need to have folks participating with their cameras on if possible. So shut the door, get yourself together. This is a group exercise. I'm all ready. I don't know if you can do that or not, but let's try to have as many people on camera as we can. And Brian, so everyone remembers Brian from orientation. Thanks for attending. I wish I could do a better job in introducing you, but there's like tornado conditions here now all of a sudden. So Brian, go ahead and introduce yourself and kick it off.
Sure. Hey guys. So it's good to virtually see you again. I wish that this wasn't all going on so we could be hooking up more in person. But nonetheless, nice to see you virtually. For those of you I have not met, my name is Brian DeAngelis. I work with Jeff really closely in the Nature Conservancy. I work across all of our North America coastal restoration work. So I sit up in the Northeast where it's been a lot colder and rainier than where you all are. but I get the good fortune to be able to work across a lot of different projects. And one of them is the Gulf Corps program, which is my favorite one by far. And what Jeff asked me to do was to help set up the monitoring for Gulf Corps. And I don't know how many of you watched the lecture recording that we posted a couple days ago, but specifically when I use the word monitoring, I'm talking about our ecological work. So showing the world that the restoration that we're doing is having good ecological impacts. That's what I've been working with Jeff on. And today, we're going to do a desktop exercise just to get us thinking about how we monitor. And then we're going to set you guys free. And you guys are going to do your own monitoring exercises outside. And I'll explain that more in a minute. So quick refresher, if you haven't watched the video, or maybe if you have, monitoring is basically all about counting stuff. So, you know, when we're doing oyster restoration or invasive species removal or Spartina planting or whatever it may be, we want to be able to demonstrate how the ecosystem is changing. And we do that by counting stuff. But we can't just go out and count the same way, you know, we normally do. One, because that would just be too hard to do. It's impossible to count every invasive species in an area we work. And we also want to count stuff so it's comparable with other people's projects and with other ways that, you know, they count, so you can compare across projects. So that's what we're going to be doing today. We're going to be focusing on how do we get abundance estimates on our restoration projects. And abundance just is a fancy word for how much of something is there. And how do we go about doing those counting exercises? And specifically, we're going to use a metric called density. Density is the number of something per unit area. And if we know the number of something per unit area, we can use that to calculate our abundance. But then we can also think about, well, how does that organism that we're counting change when we move from over here to over here? And that starts to get into distribution, how things are spread out. So we're going to start using one of the key methodologies to counting stuff for abundance and distribution. And this is just one. Remember that this is just one way of doing it. But if you got this core practice down, all the others are pretty much just variations of this. So if you're good at doing this, you can pretty much do all of them. They're just done in slightly different ways. All right, so let's get started. This is what we need. We've got an invasive species colonizing our habitat. And right now, our habitat is our desk. And we need to get a baseline assessment of these invasive species before we go out and do restoration. We need to know how many are there before we do restoration. So we're going to do a baseline assessment. So you guys need a habitat. You need a desk or a working area. If you got to use the floor, that's fine. Just cordon off an area. You know, probably shouldn't be bigger than, you know, a meter by a couple meters or 2 or 3 feet by 2 or 3 feet. You don't want it to be huge for this exercise. We also need an invasive species. This is the one I'm going to be using today. You guys can use whatever you want. You want to have enough of them where you can't just lay them out and quickly count. But don't have so many that, you know, you're going to be spending the rest of the day cleaning up after this either. So we need a habitat, we need an invasive species. We need this really important tool called a quadrat. I made mine out of cardboard. You can make yours out of, I see somebody making theirs out of sticks. You can make, you know, hopefully you have it by now, but if you don't, quickly grab a piece of paper. I see Jeff's there, and cut it out of a piece of paper. And then you need a tape measure, preferably one that's in centimeters. But if all you can find is inches, then that works for now too. We want to start getting into the habit of always measuring stuff in metrics. I know that's kind of weird and kind of scary for most of us in the US because we don't use the metric system. But in science, we want to use common languages no matter where you live. Whether you live in the US or you live in China or in Russia or Africa, we want to use common languages in science, and the common language in math is metric units. So start getting used to using metric units if you can. So we've got our table, we've got our quadrat, we've got our tape measure. You're going to need a calculator. Your phone is fine, but if you're using your phone to be on this call, you might want something else. You need something to write with, and you need a data sheet. A regular piece of paper is fine, but if you printed out that sheet that Jeff sent around, there's a data sheet on there already. Okay, so this is what we're gonna do. I'm gonna move my camera so y'all can see my desk. So I built this handy dandy. Okay, this is our habitat, okay? First thing that we need to do is we need to let our invasive species take over. So all you guys can start following along with me now, all right? So we're gonna do this together. First thing that we're gonna do is let our invasive species take over our habitat. I want you to spread out your invasive species across your habitat. Make it random. Don't think about how it goes too much. Just get it out there. Try to have pretty decent coverage of your invasive across the whole habitat. I'll give you a second for everybody to get that ready. All right. So we got to count stuff. We need to count our invasives. And in my case, all these M&Ms are invasives, and there's different varieties of these invasives. There's the green invasive, my favorite. There's the orange, the brown, the red, the blue. So I personally want to know the abundance of all these invasives, but I also want to know the abundance of the different varieties. So if you're using pasta, your varieties might be penne versus bow tie. Or if you're using, I don't know, beads or something, hopefully ones that don't roll, a green bead versus a blue bead. But this is our restoration site where we're going to be doing work. And there's way too many of these things to count. So what we need to do is we need to take subsamples. So a subsample is a sample that we're going to take that's representative of the whole. Subsample. So the example I always use, and I think I used it in the other lecture, was when your doctor wants to take a white blood cell count, they don't count every white blood cell in your body. That would be literally impossible. So what he or she does is takes a sample of your blood, and they know that that sample is representative of your whole body because your blood and your cells are distributed evenly throughout your whole body. Because we know our cells are distributed evenly throughout the whole body, we can just take one sample. Just count the cells in that one sample. And that's not your total number of cells. That's just the number of cells in that sample. And then the doctor extrapolates that across the whole body. We're going to do the same thing. But because our distribution is not even, you can see with my habitat, there's blank spots, there's clumped spots. I can't just take one sample because one sample might show me that, there's only one M&M. But we're going to have to take a number of samples to use those as representative of the whole. But to do that equation, we're going to need a couple key measurements. The first thing you got to do is measure the entire area of your habitat. So pull out your tape measure. An area is length times width. So pull out your tape measure and measure the length times the width. And then write that down on your data sheet at the top of the page. Write down the area, the length multiplied by the width. So mine is 100 centimeters by 90 centimeters, which makes life easy. So my area is 9,000 centimeters squared. 90 times 100. Now there's another key measurement that we need. This thing, this is our quadrat. This is going to be our unit of area that we use to get our representative samples. So if we know how many of these fit into our total area, then we can get an average number of our invasives per unit of this area and then multiply that by our whole area to estimate the total abundance. So I'll say that again. We're going to use this to figure out what our average density is per unit this area. So if we know what the average density is in one of these, we can then multiply what the area of this is by the total area of the habitat we care about, and that will be an estimate of how many invasives are across the whole area. So we have our area measure. Now we need the measure of our quadrat. Here's the trick though. Don't measure the outside dimensions. Measure the inside dimension. And normally that's not an issue, but if you're using something like a big thick piece of paper, measure the inside dimension. In a real life quadrat, that usually doesn't come up to be an issue. And I already know what mine is because I made it. Mine's 10 centimeters by 10 centimeters, or 100 centimeters squared. So go ahead and write down what the area of your quadrat is in your data sheet. So now what do we got to do? We've got the area of our habitat. We have the area of the sampling unit device that we're going to use. Now we got to count stuff. And the way that we count stuff is by randomly distributing these quadrats throughout our habitat and then counting how many invasives fall inside this unit. So when you're outside doing this in real life, what you do is you'd close your eyes and you'd spin and you chuck it, because you don't want to kind of throw it in a place where, you know, you're biasing your sample. So in this exercise, you just want to kind of don't think about it and toss it. And you can see in mine, or maybe you can if it's big enough, I've got 1, 2, 3, 4, 5 M&Ms. I've got 2 orange, 1 yellow, and 2 greens. So on my data sheet, on my first quadrat, I'm going to write 5 as the total number of M&Ms in my quadrat. I had 0 reds, 2 greens, 1 yellow, and this is asking me brown, but 0 browns, and I'll add another column, 2 oranges. So I want to count the total number and the variety, the number within that, the varieties within that total number. If it falls on the edge, what do? If more than half of the invasive is inside the quadrat, count it. If more than half is on the outside of the quadrat, don't count it. So go ahead and take 10 samples across your total habitat. If it lands on a total 0, count it. Don't bias your estimates. Right now, we're assuming even distribution of our invasives. So you just want to close your eyes and chuck it. If it lands on what it lands on. If it lands on no invasives, count none. So go ahead and do that and get 10 samples onto your data sheet. I want to watch you all, so I'm going to move my camera back to the normal position.
Brian, I have a question for you.
Sure thing.
What if it lands, what if it lands so that not all of it is in the area? Like, I don't know if you can see it.
If your quadrat falls out of your area of interest, rethrow it.
Okay, sure.
Good question.
Brian, I like to, in the field, throw the quadrat over my head backwards and yell science when I'm doing it.
I love that. Throwing it over your head backwards is a great way. You guys would be surprised how hard it is not to bias your quadrats. It's human instinct to want to count the stuff you care about.
So when you're in the field and you're doing this, are you modeling like this thing for a relatively small area, or like how do you pick your starting point?
That's a great question. I just plugged my my mic in. Can you still hear me? Okay. Yeah, so there's a couple ways to do it. In the field, you can, before you go into the field, if you have a huge, massive area, let's say, you're going to figure out ahead of time roughly how many samples you want in each area. So if, let's say, you have, 10 acres that you're dealing with, obviously you're not going to stand in one point and just, chuck 10 quadrats from that same point. You're going to, on a desktop, figure out already like where across that 10 acres you want to get a sample. And then you're going to hike out to each of those areas and say, well, I need 4 samples in this area. And then within that area, you're going to randomly distribute those quadrats. So a lot of that you're going to figure out ahead of time on a desktop analysis. There's another way to do it too. Right now we're taking random distribution. There's a perfectly legitimate way to do this where you can do random distribution on your computer and it finds all the points for you ahead of time. And so you just hike out to those points with a GPS and put it on that point. Or you can go back to the same spot in a more systematic way where you do like transects. You could have transects across your whole area of interest and then do quadrats along that transect. And that's just some of those variations I talked about. At the end of the day, it's all very similar, but just slight variations about how you set it up. So every project you work on might be a little bit different. And that's what I'm here for and Jeff's here for and other project managers. But the core concept of getting subsamples to apply across the whole area is the same. So I'm just going to give it a couple more minutes, let people keep collecting data.
Just a reminder to everyone, this exercise and data sheets are in the virtual programs folder, the subfolder for monitoring.
So if you're done, if you're not done, go ahead and keep counting. If you are done, go ahead and calculate the averages at the bottom of your data table. And if you don't remember how to do averages, add them all up and divide by the number of samples you took. So in the real world, we often, just while people are finishing their data collection, we often stratify our habitat areas. And what that means is we figure out how there's differences among the habitat in reference to the species that we care about. So what the heck does that mean? Well, let's say there was a big mountain in my habitat of invasive M&Ms. So there was a big hump. Well, the M&Ms wouldn't be able to live on that hump. They would all just roll off of it. So I know that in the higher elevations, my invasive M&M species wouldn't be living. So instead of just measuring my whole area, what I would do is I would stratify the higher elevations and the lower elevations, and I would treat those separately when I do my sampling. So another example of that might be if we're interested in a whole tract of land where we're doing restoration, but we're doing sampling for Spartina grass, and the tract of land where we're doing restoration runs from the salt marsh edge all the way into the deeper upland area. We could stratify that area when we're doing the sampling for the Spartina grass, because we know Spartina grass isn't going to be living way up in the uplands. And then we just break out those areas. And we could do that on our Google Earth. And then when we figure out where and how much we're going to sample, we calculate those areas differently. And that's called stratifying. Right now, we're just assuming that our invasive is completely distributed evenly across the whole area. And so we didn't worry about stratifying. Okay, so go ahead and calculate your averages. So for me, I had already done this before, so I already had my data. I know that on average, I have 8 total M&Ms per every unit of this. Now I got some zeros in there, I got some 15s in there. So I got some low numbers and some high numbers. That's why I'm using the average, because I'm taking into account all that variability. Now the average of my red M&Ms was much, much lower. The average of my red M&Ms was only 1.2. And it's okay to round. Obviously, you can't have a fraction of something, so if you want to round up or down, that's fine. Same thing with your areas. You don't have to use decimals just to make it simple for now. You guys need more time, or are we ready to keep going? And by the way, this indoor exercise is just to warm you up for your outdoor exercise. I see some people still working on their calculators, so I'll give it a couple more minutes. Okay, Jeff, you think we're ready to keep moving? Okay. So we now have the average density of our invasive. By throwing these around, we got the average number of our invasive per unit area of this thing. So that in and of itself is helpful because if you go back and do the same type of sampling before and after restoration, for example, you can see how those densities per unit area of your quadrat changes. But we also want to know how many, we want to estimate how many of these invasives are across the whole habitat. Sometimes, like for example, in the case of like invasive snails or something, we want to know what the whole population size is. So the way that we do that is we need to figure out how many of these things would fit in the total area and multiply the average density by the total area number. There's a couple ways to do that. We can take the area of this and we could, so in my case, I'm working in centimeters. And right now I have an average of 8 centimeters per 100 square. I have 8 M&Ms rather per every 100 square centimeters. And what I could do is either just divide that by 100. So I have the number of M&Ms per 1 centimeter squared. And then I could multiply that by the whole area because now I'm using the same units. Or conversely, I could just take my whole area, which for me is 9,000 centimeters squared, and I could divide it by the area of my quadrat, which is 100 centimeters squared, and I get 90. So what that means is I could fit 90 of these things into my habitat. If I laid them out end to end to end to end, I would fit 90 of these things in my habitat. So I took my whole area and I divided it by the area of my quadrat. And now, because I can fit 90 of these things in my whole habitat, I can multiply what my average density is by the area of the habitat. So for my case, I could fit 90 of these across my habitat. And my average density was 8. So that's 90 times 8. I think that's 720. So my estimate was 720 M&Ms per my habitat.
Looks like it just started. I don't know.
And I could do that same estimate for any color invasive that I have. It's the exact same. You're just using the different, using not the density of all of them, but just the density of one of them. So does everyone understand that math before I give you your individual exercises?
No, can you repeat that for me one more time, please?
Absolutely. Usually, and I'll start off by saying, when I'm in the field, what I like to do is I like to use a 1 meter squared quadrat. So it's 1 meter by 1 meter. And the reason why I like that is because it makes the math simple. Because it's 1 meter squared, I can just take whatever my density is, my average density of that 1 meter squared, and I can just multiply it by the total habitat area. Because the answer, it's 1 meter squared. But right now, my unit of this thing is 100 centimeters squared. So what I need to do is I need to figure out how many of these boxes fit into my total habitat area, right? So here's my total habitat area. I need to know how many of these fit inside this whole area. And that's just a division problem. I take the area of my whole habitat and I divide it by the area of my square. And that's how many of these can fit into your whole area. But then because we calculated the average number of invasives that we found over multiple samples in one of these, we can take that average number and multiply it by that number that we just got. And if that's confusing, what Jeff or I can do is we can, while you guys are out after this, I can write that down and send it out. And then that way you can use it as a guide when you're out doing your outside exercise. So here's what you guys are going to do. You guys are going to go apply this same approach to your own backyards. Or if you don't have a backyard, you can go to a local park or you know, a large garden or wherever you want to work. And after you pick that area of study, let's say it's a small section of a park or something, you got to identify something that you want to estimate the density and the total abundance of, the exact same way that we just did it here. So, you know, for me, like clovers would be a perfect thing to do because there's a ton of clovers in my grass. Way too many that I could ever count individually, but I could do some estimating with the approach that we just used. Maybe for you, it's, you know, dandelions or whatever. Don't make it like a squirrel or a bird because you chuck a quadrat at them and they're going to fly away. So make it something that's relatively immobile. What you guys are going to do is you're going to do the same approach. You're going to go out and measure that total area that you're estimating across. So clearly you're going to need a tape measure that's a lot bigger than the one that we just used here. If you can't find, you know, a tape measure for that, use steps. You know, generally a big human step is about 1 meter. So if you have to estimate that way, you can estimate your area that way. The other thing that you're going to do is have to remake your quadrat. Clearly, I don't want to go outside and try to estimate the clovers in my backyard using this. This is for our little indoor exercise. Typically, when we're working in the field, we use, like I said, a 1 meter squared quadrat. So it's 1 meter by 1 meter, or a 1/4 meter squared quadrat, which is 1/2 of a meter going up one way, 1/2 of a meter going up the other. 0.5 times 0.5 equals a 1/4 meter squared quadrat. You guys are welcome to make any size you want. but those are two common sizes typically used in the field. So you're going to do the same thing. You're going to pick your area, your habitat of interest. You're going to pick the organism that you're estimating the population of. You're going to measure your area of habitat. You're going to measure the area of the quadrat you make. Maybe you guys already have one around for previous Gulf Corps work. And then you're going to go outside and do some random distributed sampling. Like Jeff said, a great way to do that is to kind of close your eyes and throw it over your back. Try to distribute that sampling pretty evenly around your area of study. Because for now, we're going to assume that our area, our organism is uniformly distributed across that area. And then what we want you guys to do is answer these questions and get them back to us. So we want you to describe the area you chose. You know, was it your yard, a park, something else? And why did you choose that area? Tell us what organism you chose to measure. You know, was it a clover, a weed, a flower, something else? And why did you choose that? What was the total area of the habitat you chose to measure? And what was the size and area of the quadrat you chose to use? And then tell us why you chose this size. And then when you're all done, tell us if it seemed like the right size. Because sometimes it can be too big and sometimes it can be too small. And as you're outside doing your sampling, I want you to think about that and what would be the ramifications and the trade-offs by using something too small versus using something too big. How many samples? I'm going to leave it up to you guys to determine how many samples you do this. So if you're working in your backyard, how many times are you going to throw your quadrat? And how did you pick that number? And then I want you to think about, well, what's the trade-offs between doing too many versus not doing enough? And then I want you to do the math. Getting the average density. So the average density, let's say you're counting clovers. You're going to do the average the same way. Add up the counts of clovers in each of your quadrats, divide by the number of samples you took, and then multiply that average density across the entire area of the habitat. Does that make sense? I know it's difficult. This is a tough one. But that's the point. The point is to get you guys out there and get some experience with it and get comfortable with it. So when we're out there doing it for Gulf Corps, you've struggled through it. So this isn't about being right. You're not going to get graded on how right or wrong your answers are. We're going to take a look at the effort you put into it. So that's pretty much it for me. Jeff, you got anything else you want to talk about?
No, Brian, I'm good. I know when I insert links into the chat box, it doesn't let you click on it to link, but you should be able to highlight the text to the Google Drive folder and then enter it into your browser. It's a folder that's open to everyone, and so you're welcome to use it. And this presentation, once the recording is completed, will be put in there, as well as all the data sheets and the monitoring guide and the exercise that went along with this call. And so I think we're offering 2 hours of time if you all can complete these data sheets and turn them into your either your leaders or your core staff, however you usually do that work. And we look forward to seeing all of your data sheets and seeing what you guys come up with.
Yeah, same. Thanks for logging on, guys.
Does anyone have any last minute questions or follow-up questions?
All right.
Okay.
Nice seeing you.
Thank you, Brian. I appreciate everything. Good luck, everyone. Talk to you soon. Have a good rest of your week.
Bye, y'all. Go golf course.